Hello, my name's Steve Kerr. I am the creator of the fellow child project Manned Spacecraft Design concept. Recently, I was doing a demonstration of the PRISMA3D, of an earlier version of PRISMA3D, and I would use the this Parasite Fighter project to demonstrate the old version, the old update versus the new update of the version 3. And that's not it. That's the Outerspace. Okay, this is the project. Well, this is the project I was using for demonstrating, but I was online because I did the, I went on the YouTube, I went on the internet to look up the Goblin, shows what the Goblin looked like. And because I did that, this project got updated, so it now uses the present version, the current version, update version of the PRISMA3D version 3. So I'm going to be basically doing this again for my Spacefighter. I'm going to create a Spacefighter using this format, sort of, but it's a Parasite. Let's see, where's my model? And what I did was oh, that it's 9. Okay, I gotta update that. So that's the model hall. This is the Flower Child project, Flower Child spacecraft concept, and this is the Apollo lunar lander, and that's the human habitation volume. And this is a Parasite fighter. Space fighter based on the jet fighter. So I'm going to redo this from scratch. Now the model, the Flower Child model, is a civilian colony spacecraft design. It's a non-weaponized spacecraft. And I call it the model because it's modeled off of the main hull. Starting point for the hull size is based on the volume of the World War II battleship, the model. And so, and the reason I use the World War II battleship model as a base size is because, in talking about outer space spacecraft designs, I have to reference, I'm not an aerospace engineer, so I'm referencing science fiction franchises. And Space Battleship Remodel, aka Star Blazers, I'm familiar with Star Blazers being an American. I'm referencing that's the fictional spaceship design. The fictionalized version of the model is the only spacecraft design, fictional spacecraft design, that's based on any real life planetary bound vehicles that Earth humans have made. So the based on my calculations from watching a TV series, and not from reading books and stuff that are made by the guys or people who fan fiction, data books on the spacecraft and stuff. I'm just basing everything on what I see on a TV set, and based on that, I believe that the 1970 Space Battleship remodel is between 100 feet and 200 feet approximately, give or take. Feet longer than the World War II battleship remodel. The current version, based on what I see on the TV set on the YouTube videos, the current rebooted version looks like it's about 500 feet, if not more, longer than the World War II battleship remodel. But that's, that's based on what I see on the screen, and not based on what people the creators have said, and wherever, or whatever, or other resources concerning that. Okay, so let's get out of this. Parasite Fighter. Okay, now what this is. That's the engine module. Okay, you're going to have, there's an engine motor inside, and the nozzle sticks out this way. You're going to have an engine module on top of here, and the engine is going to go up, facing upwards, and then downwards, left and right. So, let's see here. Did I get my orientation correct? Okay, I have to do, oh, I gotta change the text. And in previous versions, version 2 and version 1, you can do much longer text, and I kind of miss that. Because I write a lot. Okay. Okay, now okay, let's go to okay. Now what I'm doing here is, yeah. Oh, okay, the top, since it's text, okay. The nozzle is going to be, the engine is going to be 5 feet and 5 feet, this is not a F1 STQ engine design. Okay, this is a different engine scale. but it's cryogenic, multi-start variable thrust capability. But it's a bigger engine. It's 5 feet by 5 feet by 5 feet in volume. I'm going to move it. $150. That's 9 feet. That's 4. This is 5. So that's 6.5. Nope. 150. What? No. Undo. Move it. Okay, that is off. We're gonna go 3 so we can see what's going on there. Okay. I'm gonna have a number on that thing. Okay. So engine, motor top, or up. Okay. Again, we're doing the same thing. Scale 5. We're going to move it. This is under 50 feet. That's 9 feet. That's 4. 150. 141. Okay, that's not good enough. 3 so you can see what's going on. They're eating each other. Okay, let's go. And they're eating each other right now. So, ooh. They're not even, okay, so. Oh, yeah, okay. So, oh, need to do that. Okay. And then that. And then more top, bottom. Cube. Uh, let's get rid of that. It doesn't matter how you do that, it doesn't stick, so. Okay, this, okay. We're gonna move it 3, wait. 45. Move, okay, 5, 6, they're not each other. Okay, and then that engine motor depth. Okay, we're going -6, okay. Okay, and we got that. There we go. Engine motor right. Sound good? Scale that. Okay, wait a minute. Okay. 10. 10. See? We're going to move that. Okay, so, okay, now. Five. 0.1. And then we're going to move it down to 5. Okay, now, oops, cylinder. Like that. So now we're going to make 5 of these. Copy. 1, 2, 3, 4, 5. Okay, the first one is going to go up. $150. Okay. Okay. Okay, we're going to move it to let's move it over so we can see what's going on here. Oops, wrong way. Alright, 135, 136, 137, that's eaten in it, 6.5. Okay, that's good. Okay, 6.5. Yeah, okay, and we're going to name that. And then nozzle bottom. Using top and bottom, not up and down. Okay, now go to this guy. And 80. And moving this to 160. This is 5, and 63.5. Renaming that. Engine, nozzle. Oh, I should just get that top. Okay. Actually, these are not going to be gimballed. These are going to be fixed. Okay. Yeah, tapping on the list hits the top thing first, which is basically now previous when I was working on the other project the other day, when you create an object, except for the text, you had the one of these other objects that's not text, it automatically gets grouped into that object. But right now, what they've done is they kept the project name on the top of the list, and so there's no automatic, when you create an object, it doesn't automatically get grouped. So but Yeah, so that's okay. Okay, okay, what? There we go. Okay, now not that one. That one. Okay. This gonna go up to 150. Okay. 7. Okay, so we need to go 12. Oops, wrong 12. 12. Oops. Uh, 13.5. I'm gonna name that. Engine nozzle, right? Okay. Oh, 270. 90 plus 180 is 270. $50, 13.5. I said 13. I missed that. That's my targeting is bad. 13.5. Okay, here we go. Okay. Engine nozzle. Yeah, I was assaulted back in 18 March 2020, and the guy kept on hitting my left eye. And so I can't, even before that I was missing, but since then I miss a lot more. Also astigmatism, and prior to the physical assault I could see things clearly without astigmatism about 6 to 9 inches. But since the like this distance prior to the physical assault, because astigmatism, everything would be blurry. Because prior to there'd be no blur. But since the physical assault, there's blur. There is always astigmatism. There's no range in which there is no astigmatism. So, and that affects things a lot. And so, okay, and then we go to this guy. Let's see what's... rotate this way. Direction. Okay. That's 270. And then we move that up to 150. Target. We will move that over now. Oops. So because the is okay. What I've done here. Let's get all this. The engine module is the center of gravity or center point of the spacecraft design. So the spacecraft. The rotation is going to be centered around the engine module, the center point of the engine module. So the engine module is the center, is the center. Okay, so moving from 0 to 10, okay. Going right, so I gotta go -10. Nine, 8.5. Rename that. Engine nozzle center. It can also be named main. I'm naming it the center because it's the center of the form. So that's the main propulsion system. That's the propulsion system for the spacecraft. It goes forward, you push that, it'll move it down, and so actually what will happen is this thing pushes it forward, this will make it go that way, bottom one will make it this way, the front one here will make it go that way, and the back one will make it go this way. So, okay. Now we need fuel for these guys. So what we have here, 5, 10, 15, 16, 17. Okay, 5, 6, 7, 21, okay. Alright, let's see here. Now, when it comes to fuel tankage and stuff, I'm still using my Flower Child project theories. So, okay. Module. Okay, we're going to do a sphere. Seven feet. We're doing, okay. Tankage is going to be 5 feet in diameter. Oops. Get rid of that. What did I get rid of? Okay, whatever. So, scale 5, 5, 5. So that's orientated. We're going to rotate I like that. I do not like that at all. Okay, now. Okay. Normally I do color coding, but I'm not doing color coding right now. It complicates things with the new version. So this needs to go 150. XYZ. That's 9, that's 4.5. Plus 2.5, that's 7. Yeah. Okay. Copy. Now I'm going to make the assumption that 1 hydrogen and 2 oxygens is maximum burn. I'm going to move that over 2. I'm going to move that over 1. Yeah. Okay, what's your center point? Oops. $13, okay. Oh. That's not even going to be adequate. Okay, that's not that. Okay, I'm going to have to change the... 10 plus 15, okay. So, oops, wrong one. So the fuel tankage is going to be 15 and do I sometimes forget to eliminate. I don't know, yeah, I sometimes forget to eliminate the numbers, and sometimes I don't eliminate, if like the 2 or 3 numbers, I don't always, or there's a decimal, I don't always eliminate all of them. And so when I type in a number, it's instead of, I'm typing in 15, I end up with 115. Or if I put 100, and 1,000, it's, you know, that's me. That's the type of errors I make. That has nothing to do with PRISMA3D. Model that. Rotate. No, get out of that. Nice. Okay, I can let the program. Rotate and and 50 is the base height of the vehicle. The model is 15. Okay, moving it. 13, 12, 11. Okay. So I'm doing 1-foot frame structures, so the fuel module is going to be 1 foot thick, And then the fuel tank, the propulsion. Well, I can do this two different ways. I can do the fuel module, and it'll be stuck in there. And then I do the oxidizer module. That's separate, and put them separate. Okay, I'll do that. So, oops, okay. Rename. I'm going to call it a fuel module right now. No, fuel tank. All 5 engines are going to be using this fuel tank. Now, okay, let's get out of this. Okay, project name text. Okay, there we go. Now, the way this is designed, and that's the jet engine. This is the Parasite fighter, jet fighter. So that's the jet engine, and this exhausts, and that's the fuel tank, and that's filled. So it has 2 fuel tanks, and then that's the air intake, and these are weapon bays. And this is the cockpit, the main wing, the elevator, also known as a stabilizer, and rotors. It is a competitor to the F-85 Goblin. Okay, so now what I was thinking for weapon base, that this would have machine guns or cannons in here. The weapon bay, the fuel tanks, is 4 feet by 8 feet. It's a human volume, and just residential volume that I use for the Fairchild project, but they're in cylinders. So that's why. Okay, so now the difference between this Parasite fighter, the jet fighter, and the Parasite Spacefighter is that the engine is, this would be the engine here. Well, let's go to the proper section. This would be the engine with the nozzle and stuff. And then there'd be an engine nozzle here, engine nozzle, engine motor nozzle, and motor nozzle. And then you have fuel tankage to fuel all 5 motors. This does not, so as a Parasite fighter, you're not going to have the same amount of endurance, flight endurance, that you would have in a standard jet fighter. For example, the F-15 Eagle or the F-16 Falcons. Okay, they can fly without without external tanks about an hour. They have about 2 hours flight. 1 hour to the destination, about 15 minutes loitering time, which is air combat, and then an hour back to base. Approximately 45 to 60 minutes. That's a standard range for modern day jet fighters. And so, a Parasite fighter would just have enough fuel to loiter around, launch from its mothership, which would be like a B-52 or a B-36 or the C-130s. C-130 Parasite, yeah, that'd be interesting. Mothership that does nothing but air combat has Parasite fighters. That'd be an interesting concept. So these basically have about 15 minutes of flight time, air combat, and then either dock back to the mothership or heads to the ground and land on the ground. Those are its two options. You know, or run out of fuel and crash with no land with no fuel. It'd be a glider, basically. Coming in for the ground. Okay. So that's what I'm working with. So basically with the Apollo 75 space vehicle, the S1C stage has about 15 minutes of flight capability. That's to launch the entire vehicle off the launch pad and get into the stratosphere. It takes about 15 minutes to do that. And then it's run out of fuel, and then the SC stage kicks in to put it in Earth's orbit, and then the S3 stage kicks in to put it in Earth's orbit, to have an orbit around the Earth, and then shoot it to the moon. Okay, let's see here. Go back to that. I got nothing there, okay. So, okay. So what I can do is I can say move over rover. Let Jamie take over. What the? Oh, okay. That is. Yeah, the project name took over. Okay, remove it. Hey, we can do that, and then we can copy that. Move to -8, and we have two tanks. Let's do that. So that's point. Okay, so 0.5. That's 1. Okay, so now you have the now we were to make a okay, you're 12, okay, 8.5, okay. So let's make, let's see, nothing's highlighted. Okay, let's do this. Rename. Fuel tank left. And then fuel tank. Right. Now, I do not know, I'm not an aerospace engineer. I'm not a rocket scientist. I'm not an astrophysicist. So I do not know the actual, these are the external measurements of the fuel tank. I don't know how thick the tank is, but I'm going to assume that the tank walls, the tank structure, is about 1 foot thick to deal with the cryogenic temperatures of the hydrogen and the cryogenic temperatures of the oxygen. So these fuel tanks are 15 feet in diameter. The actual interior volume, gas volume, the liquid volume, is 15 feet, 13 feet in diameter in the sphere. Okay, now let's do this. Okay, so nope, wrong one. Delete that. It needs to be a cylinder. And make sure that it's highlighted. Rotate it 90 degrees. Okay. Now the tank, the fuel tank is 15 feet diameter. Okay. Okay, scale that up. 17, 17. Now this represents the exterior of the structure, which would include the frame and the skin, theoretically. As I said before, and I've said almost all the time, I'm not an aerospace engineer. I'm not a rocket scientist. I'm not an astrophysicist. I do not know the numbers associated with spacecraft designs. I'm just a civilian making speculations, and these are numbers I pulled from the hat that I use for my flower child project and my other spacecraft designs. This is a non-flower child project spacecraft design, and I use the same number system, same theories. Okay, so this material let's make it transparent. 0.5 is a good number. Okay, we go back. We gotta be careful about that because you can start doing numbers on these and things get wonky. Okay, now we're gonna move it. 150 height. 12. What did I say? 8.5. So no. Okay. Material solid. Okay, the solid, no, okay. Engine on the right. Nozzle top. Nozzle right. Nope. Nozzle left. Nozzle center. Yeah, that's the reason why I don't do colors, because you're going they add all the colors. You create an object and put a new color on an object, they get in there. And for example, I do have a Android design that I'm working on. I got skin color, eye color, eyeball color, iris color, and there's a bunch of different colors going on. And it's got bone color, muscle color. You know, it's, yeah, you can have, and certain, you got transparencies and non-transparencies versions of those colors. Yeah, it's a mess. Okay, now let's center that. So let's see here. 15 divided by 5 is 3 minutes. Okay. $8.5. Okay, and we're gonna keep that. And then just copy that. Move that to negative 8.5. Now, with my flower child project, okay, these are the fuel modules. What I can do, so you have the internal structure, you have the module holding the fuel tank inside. But you can also do armor, what I call armoring. And so what I can do is move this over. Nope. We've done another half foot. And move that over another half foot. And now you have 1 foot space between the two modules, and you can have a frame structure on top of that. So you would have, for example, I'm just going to do a quickie here. Cube. I'll just move it in 50 12. So you now have, let's scale that. 17 times 2 is 34, plus 1 is 35, plus 2 is 37. And then 17 plus 2 is 19. And then again 19. So yeah, and then you can, so that would be the armor structure, or it could be it could be completed like what you do see in the science fiction spaceships. Star Trek, all the spaceships have, this would be the armor. It would be the frame structure. Or it could be an exoskeleton. Just basic framework like we see on the Space 1999 Eagle class. These can be individual bars and stuff. And what I do is, on my flower chart project, I make these transparent, so you can see what's going on the inside, like so. And let's see here. So I'm not going to mess with that. Well, yeah, okay, let's do that. Okay, now we're going to move it. $15. That's good. That's good. Okay, we want to make this visible. And let's see what's going on with the. Okay. Undo it. Okay. Yeah. Okay. So that's 14.5. We want that mod. We want the spacing between the module and the nozzle, because the nozzle is going to vibrate. So I believe 1 foot distance would be adequate. Oh, come on. Actually, see here, how did the. Now I did the. I have the. I did contact NASA. Concerning the flower chart project, they gave me an Apollo April 1970 more mission operation report supplement, version 3. They took out the data on the CSM. So But the F1 engines, I did some calculations, and there's like between there's like 5 feet between the nozzles. The nozzle can rotate a couple of degrees, maybe like 5 degrees or something. Between 2 and 5 degrees. I gotta look at the more. It's been a while. And so there's a minimum about 1 foot space between the inboard engine, the center engine, which does not gimbal, and the outboard engines, which do gimbal. So I think 1 foot would be satisfactory. So that means the cylinders is going to have to move to 15.5. And the bottom one and the top one. Okay, and then we got the fuel tanks. Okay, we're gonna have to move that. Come on. Okay. Cylinder, get out of there. We named that. Fuel module. Left. And then that. Fuel module. Right. Right. I said right. Okay. Okay. Likewise, what I can do, not necessarily. Okay, we're going to have to create an armor structure to connect everything. So what we're going to do, what I'm going to do is this. Okay, that's 9 feet. Okay, we'll just cube it. Okay, that's 7, yeah. it, oh, I need to name. So we're going to name this for fuel armor. Oops. Fuel armor. Basically, it's a okay. And then we go to this guy here. Everything's 9 feet. And for the engine module. And then we're going to add 10 more feet because the motors are 5 feet each. Yep, I got to do that again. Okay. Nine plus 10 is 19. Oops. Wait, that's the XYZ. That's, oh crap. 9. That's 19. And that's 19. Move that to 150. Okay. Move that. 1. Okay. $1.5 should touch it. Yep. 2.5. So now this thing has to be 10. Nope, 10.5. No, 9.5. Nope. Nine point five. I said 5. Okay, let's look at that. One divided by 19 is what? Okay, we're just about to redo that. Project name text, and keep it simple. And then we want to change the text to STQ Parasite Spacefighter. I want to use the term outer Spacefighter, but it doesn't. The text line does not allow for it. Scale 10, 10. Move. $110. Okay, now. So that's 9.5. Okay. Okay, scale that. 9.5. And we said 19 because 10 for the the module is 9, and the motors are 5 feet each times 2, so it's 19. And then we move it to 150. And then we move it to ½ inch. Yep. 1.25. 25. So that is called engine armor. And basically what it is, it's a frame structure that to mount the engine section to the fuel section. Now this. Oh, now you're on the top of the list. Yes. Wait. Who are you? What's that all about? Uh-oh. Undo. Okay, we got engine armor, fuel tanks. No. Okay, got the engine module. Okay, the engine module supports the engine motor, so there is no motor center. It's inside the module. Although I should probably make one, but I'm being lazy. Okay, do you want to cancel that? We got root. So what the hell? Undo. Yeah. Oh. Oh, the engine armor. Okay. All right, let's see this. It's not, nothing's grouped to it. Cancel that. No. Hello. What the hell? No. You used to be able to, and in the previous variants to version 3, you were able to shift the organization by putting these guys out, just putting it outside, and then they realign themselves. They don't do that now. And I was trying to do that, and I can't reorganize. Okay, we need to rename this. And that's the engine armor. Now actually the list will fix itself if I exit, so that's one I'm going to exit. See what happens now. Okay, rename it. Yes. Okay, let's see what that does. Engine nozzle. Oh, good. Okay, I don't know what that's all about. Okay, nope. Since that's the top, it's going to... Nope, that's not what I want. I want the fuel armor. And I want to hide that. hide. No, that's not it. The fuel module. Like that. Like that. Scale that. 4 feet. 4 feet. 8 feet. And then that. Human volume. Human habitation volume. Okay, we're going with another 50 feet. 10. Nope. Minus 50. That's a big day. So we have an idea how big the spacecraft is. Nope. I'll take that. Copy. Move. Okay. That's 15 feet in diameter. So, and then that's 30.5. Copy. 45.5, not 5. Rename that rear, oops, or back. and then that middle rename that front. And move it 2 more. 47.5. I want to have 1 foot space between the two, between the tanks. That'd be 31.5. So now, lift module is going to hide that. Move that to 31.5. We scale that. Need that. Cylinder. And then that. Fuel module left. $31.5. Rotate it first. Move it to 150. $31.5. 15 times 3 is 45, 46, 47, 48, 49. $49. Okay, well, and then that's 17. Okay. And that is 17. Oh. I forgot I got an 8.5. Material everything is going to go back to 0.5. Whatever. Copy it, and then to the right, and then we move it to negative 8.5. And I think that's going to be it for this video.